Welcome back to Step Electrical. Now we are here in mesh analysis series, and this is the part 3 of mesh analysis series. We learn how to deal with type 2 circuit. Okay, so let's begin. You can see in this figure that in this figure there are two voltage sources, and along with these two voltage sources there is also a current source. That this current source is not connected with any resistance, or we can say that there is no resistance connected in parallel with this current source. That's why this current source is not transformable into voltage source. So from this we can conclude the title of this video, and the title of this video is circuit containing current source along with the voltage source. Okay, now you can see that there are three loops, so let's assume the loops. This one is the first loop, this is the second loop, and this one is the third loop. Okay, we will also assume the currents. So I1 is the current flowing through this loop 1, I2 is the current flowing through this loop 2, and I3 is the current flowing through this loop 3. And these all currents are flowing in each loop in clockwise direction. So this is the very first assumption that we have to do in every mesh analysis. Now in loop 1, as you observe carefully, you can see as this current source lying on the circumference of this loop 1, we can conclude that I1 is the current supplied by this current source. That is I1 equals Is equal to As we got the value of I1, so we only have to find out the values of I2 and I3, and we will only apply KVL in loop 2 and loop 3. I2 and I3 are the unknown values, so let's apply KVL in loop 2 and loop 3. Applying KVL in loop 2, we can write minus V2 minus I2 minus I1 into R2 minus I2 minus I3 into R3 is equal to 0. You can see that this I2 current is flowing from the positive terminal of the battery to the negative terminal. That's why we write minus V2 and minus I2 minus I1. This I2 through this R2, we can see that I2 as well as I1 current both flows, but I2 is the loop current of the loop 2. That's why we write I2 minus I1. And this negative sign is for potential drop across this resistor R2. And it is similar for this R3. So on simplifying this equation, we can write R2 into I1 minus R2 plus R3 into I2 plus R3 into I3 is equal to V2. Now it's time to replace this I1 by its value Is. So on replacing, we can write R2 into Is minus R2 plus R3 into I2 plus R3 into I3 is equal to V2. So this is the first equation. Okay. Now let's apply KVL in loop 3. So on applying KVL in loop 3, we can write V3 minus I3 into V4 minus I3 minus I2 into R3 minus I3 minus I1 into R1 is equal to 0. So here V3 is positive. Why? Because this I3 current flows from negative to the positive terminals. Okay, so it is positive, and rest you know. On simplifying, we can write R1 into Is plus R3 into I2 minus R1 plus R4 plus R3 into I3 is equal to minus V3. We have just replaced the value of I1 by Is. So this is the second equation. Now on solving these two equations, this equation and this equation, we can get the values of I2 and I3. Okay, so this is all about the general analysis of type 2 circuit. Now we will solve a numerical. Let's solve the numerical. You can see that the value of Is is 5 ampere, and so you can conclude that I1 is equal to 5 ampere. Okay, so we can write I1 equals Is is equal to 5 ampere, and we don't have to apply KVL in loop 1 as this current source is lying on the circumference of this loop 1. Now we will only apply KVL in loop 2 as well as in loop 3. So let's apply KVL in loop 2. On applying KVL in loop 2, we can write minus 5 minus I2 minus I1 into 8 minus I2 minus I3 into 4 equals 0. And on further simplifying, we can write 8I1 minus 12I2 plus 4I3 is equal to 5. And how I have written, you better know. As this current source is flowing from this positive to negative, that's why it is minus 5. And through this one, 8 ohm I2 current as well as I1 current both flows, and I2 is the current of this loop 2. That's why we write I2 minus I1 into 8 minus I2 minus I3 into 4 is equal to 0. So on simplifying, we write 8I1 minus 12I2 plus 4I3 is equal to 5. And on replacing the value of I1 by 5, we can write 8 into 5 minus 12I2 plus 4I3 is equal to 5. And on further simplifying this equation, we can write minus 12I2 plus 4I3 is equal to minus 35. So this is the first equation. Now let's apply KVL in loop 3. So on applying KVL in loop 3, we can write 10 minus I3 into 6 minus I3 minus I2 into 4 minus I3 minus I1 into 5 is equal to 0. Here 10 volt plus 10. Why? Because this current is flowing from negative to the positive. I3 current is flowing from negative to positive. That's why it is plus 10. and minus I3 into 6 minus I3 minus I2. Why I3 minus I2 into 4? Because I3 is the current of this loop 3 and I2 is the current of loop 2, and we give highest priority to this loop current I3. That's why it is I3 minus I2 into 4. Similarly, I3 minus I1 into 5 is equal to 0. Okay, so on simplifying, we can write 5I1 plus 4I2 minus 15I3 is equal to minus 10, and on replacing the value of I1 by Is, that is equal to 5 ampere, we can write 5 into 5 plus 4I2 minus 15I3 is equal to minus 10. So on further simplifying this equation, we can write 4I2 minus 15I3 is equal to minus 35. So we have obtained two equations, and on solving these two equations, we can easily get the values of I2 and I3. So on solving, we will get the value of I2 as 4.05 ampere and I3 equals 3.42 ampere. Thanks for watching this video till the end, and if you found this video helpful and interesting, please like this video, share this video with your friends, and drop a valuable suggestion in the comment box. And if you haven't subscribed this channel yet, please subscribe this channel.